Well, good afternoon, viewers. Today we have a 2014 Hyundai Tucson. The customer reported they were driving at home this afternoon and it lost power and the MIL started flashing. So let's have a look here. They were able to drive it here with reduced power. Now you can see the check engine light is flashing, but it's not misfiring. So that's odd. Normally when the check engine light flashes like that, it indicates a severe misfire is occurring. Well, obviously there's going to be some codes attached to this, so we're going to scan it and see what the computer has to say about this problem. Okay, so we're going to scan this thing. I've worked on this thing before. In fact, it's got a history of an evap system leak. I've got a vent solenoid put in it, but that was a minor problem. Key is on. Clean battery charger connected, set at 13.5 volts. It's only 11.9, so my battery charger must not be connected. I'm going to make sure. Okay, so it's auto ID. Now it's at 13 volts, so my battery charger table popped off the positive battery post. Let's do a network code scan. Engine's not running, keys on. This will take several seconds. Knox signal range performance. Well, that's interesting. Why would that? There's no noise in the engine, not that I could hear. And that's making the check engine light flash? That's interesting. P1326. I don't think I've ever recalled seeing that code on a Hyundai. And it's pending, it's not even current. Well, we'll pick up when we get to the end of this code scan. So in the engine control computer we have P1326 pending code for the Knox signal range. And over here we have an evap code and the large leak code. That's what I ordered a vent solenoid for a week ago. I do have that part and we are going to put it in, but why do we have this 1326 code? Let's go into the engine and see if there's any kind of data related. Let's see if the Snap-on troubleshooter will give us anything on 1326. P13, no, P12. Alright, well, I'll do a little research. So the code that's pending is a P1326. And if I go in here and type in keyword search for P1326 on a 2014 Tucson, it comes up not found. Interesting. Well, let's try knock sensor. I wonder if we got some rodent activity. So this is a 2-liter P0326. P0326. I wonder if the scan tool is misreporting it. So it's under the intake manifold. Yeah, it's under the intake manifold. Well, at least we're going to have a visual inspection of it. So I'm looking for data parameters related to the knock sensor, and I thought I might as well look at misfire counters. So you can see cylinder 1, 2, 3, and 4 are not showing current misfires, yet the check engine light is flashing right now as I speak. And it hasn't counted any misfires. So this has to be a programmed event. The knock sensor is under the intake manifold. I can't see it from the top. I'm about to lift it up on the hoist to look at it. In the ignition data list, there is no knock sensor activity, but it does have spark timing for each cylinder. You can see it's adjusting the spark timing probably to stabilize the idle speed. Why wouldn't they have knock sensor activity in this ignition data list? It's not in the misfire data list. Let's try this feedback value. That's probably fuel trims. Okay, here we go. Knock control adaption. Knock control adaption. Ignition 1 retard due to knock control. Now, it could be that because there's an active fault code, this is all defeated. There's no noise out of the engine, so no abnormal valve train noise or anything like that. Let's clear this. Let's clear the code from it. See if I can clear it with it running. Codes. Let's go back into that data list and see if there's any kind of, that was misfire data. Not in the ignition data where you think it would be snap-on. No, that was in the feedback data list. Feedback value data. Which what I would have thought would have been fuel trims. So there's no knock retard now. Torque increase request from TCU. Number of DTCs, 0. Knock control adaption, 0, 0, 0. Well, I'm going to see if the check engine light is currently flashing. So the check engine light is off. Fuel tank is about 3/4 of a tank, so the customer didn't just buy fuel and put bad fuel in it. Well, let's have a look at underneath this vehicle and see if we can see any evidence of a problem with that knock sensor or wires. So I removed the oil filter access panel and looked up beside the starter under the intake with a bore scope, and I can't see any evidence of rodents in that area. They show it directly above the oil filter under the intake manifold, and although I can't see it with the bore scope, I don't see any evidence of mice or squirrels in there. Well, if I search for P1326, I can find no cases on it, so it doesn't appear to be a common code. Here's the DTC information. It doesn't mention anything about flashing the MIL, but once I cleared the code, the MIL is no longer flashing. It says diagnostic time is continuous, MIL on condition, DTC only. It doesn't even say it'll turn the check engine light on. It says it's only a diagnostic code. So somebody's lying. So then I go to component inspection, knock sensor range performance troubleshooting for this P1326, and here's the factory troubleshooting step. Substitute with a known good knock sensor and check for proper operation. Thank you very much. Just change it and see what happens. It's under the intake manifold, so it's not 5 minutes. It's not like you can just swap it out. You don't have anything better to do than that? Wow. How about this one? Connect GDS to DLC, warm up the engine, monitor knock sensor parameter on the current data with GDS. Are the parameters displayed correctly? Well, I was watching it and they were all zeros. Knock control adaptation value, cylinder 1, 2, 3, and 4. They were all zeros. Fault is intermittent, caused by poor contact in the sensor or the ECM connector, or was repaired and the ECM PCM memory was not cleared. Thoroughly check connections for looseness, poor connection, bending, corrosion, contamination, deterioration, or damage. Repair or replace as necessary and go to verification. Go to terminal and connector inspection procedure. Wow. So obviously this is an intermittent. It might be the knock sensor, but I'd like to find some cases on it, and I can't. So we're doing a network code clear. I did change that vent solenoid beside the gas tank. I had previously diagnosed that last week. It's got nothing to do with this knock sensor code. I had a look under the engine cover, and I don't see any evidence of wiring damage. I'm going to clear the codes and take it for a road test and see what happens. Well, I just came back from about a 15 kilometer road test. The car runs perfect. So I'm going to save this recording of ignition retard due to knock and knock sensor adaptation and have a look at the data. File, save, collected data. It's an import 2014 TUCSON. Let's save this file. I'm going to exit here and go back. And view it in ShopStream Connect. It is going to open it. See if there's any unusual knock activity on any one of the 4 cylinders. Okay, so where are they? Cylinder 2. Let's put down this one over here. This one here. This one here. And this one here. So there was a little bit of activity on cylinder 2, cylinder 3, and cylinder 4, but 1.5 to 2.25 degrees is not unusual, in my opinion. Which cylinder is this? Let's see if I can. So that's cylinder 2, 3, 4, and 1. That's the entire recording. 5,653 frames. So I don't know what to suggest with this vehicle. It runs perfect right now. Probably going to drive it again tomorrow and see if it'll act up. Do a little research tonight and see if I can find any other cases on it. I don't know if I should be searching for P1326 or P0356. I think that was the code. (1326) or 0326. Well, we'll see. Do some research. On a positive note, on that road test, the evap system monitor ran and passed. Test complete. O2 sensor not complete. VGR complete. Misfire not supported. Really? Catalyst not supported. But this that's a different ECU ID number 2. So evap system catalyst test complete. So I wonder why it lists 2 ECUs. ECU ID number 2. I guess just because they can. Well, hopefully the P0455 code is corrected now, but that doesn't explain the P1326 or P0326. So doing some research last night on Google, believe it or not, for a P1326 on a Hyundai, came across several cases and several situations where it says the knock sensor detection system detects vibrations indicating the onset of excessive connecting rod bearing wear. It's designed to alert the driver at an early stage of bearing wear before the occurrence of severe engine damage, including engine failure. If vibrations caused by bearing wear start to occur, the malfunction indicator light will blink continuously and the vehicle will be placed in limp home mode. This will reduce further engine damage and the engine and ensure that the vehicle occupants are not exposed to the risk of a more severe engine failure. At that time, diagnostic trouble code P1326 specific to the KSDS will be recorded in the ECU. The vehicle can continue to be operated for a limited time in limp home mode, but it will accelerate slowly and at reduced maximum speed. Also, engine RPMs will be limited to approximately 1800 to 2000 RPM. So that explains what was going on and why the check engine light was flashing, but there were no reports of engine noise. I've checked the engine oil, it's clean, it was recently replaced. I found lots of cases where this has been occurring due to a wiring harness or wiring issues, and I'm checking to see if there's any TSBs on it. Not specific to the 14 Tucson, but newer 15s and 16 Santa Fe's and such, I found bulletins. So I'm still searching. So back on the 14 Tucson, I searched for the keyword search of just the word knock, and I find a couple of TSBs. One is the use of aftermarket engine oil filters causing engine knocking noise. Interesting. Let's see what that has to say. Now this has obviously got an aftermarket engine oil filter on it, superseded by 12EM06. So let's close that one. Why not just delete the existing one? Some vehicles may experience a knock noise with the use of an aftermarket oil filter. May use different materials, constructions, and specifications than genuine Hyundai oil filters, which lead to pressure variations within the engine, thus contributing to an engine knocking noise. Well, that was useful. Gotta love it when the manufacturer blames aftermarket parts. Chances are their filters are fabricated by the same companies anyways, just with the Hyundai nameplate on them. Well, I know it's got a Wix oil filter on it. I'm going to make sure it's the correct one. So I found a video on YouTube here for Hyundai Kia 1326 diagnosis. And Hyundai Kia has a special tool for checking connecting rod bearing clearances without removing the connecting rod. They put air pressure in the cylinder and vacuum in the cylinder and measure the up and down movement of the piston with this special dial indicator and arrangement that they have. And if the bearing clearance is excessive, they replace the engine. If the bearing clearance is good, they replace the knock sensor and reroute the wiring harness away from the injector harness, from what I can see. But I'm still looking for the actual TSB on this, and I haven't found it yet. I've got a friend at the Hyundai dealership here in town. I've sent them a message and asked if there's any TSBs. There could also be a flash update to address this problem with the ECM and relaxing the criteria for setting the code, but haven't come up with a game plan yet as to how we're going to attack this. So here's what I've learned. I found this YouTube channel on YouTube, S&E's Garage. Guy seems very knowledgeable. I'll put a link in the description to the two videos that I found. There are several revisions and several campaigns that could apply potentially to this vehicle, but I can't find out any specifics. I'm still waiting for my buddy from Hyundai to call me. They have a history of connecting rod bearing failure, and initially it was causing rod bearings or connecting rods to go through the side of the block and vehicles to catch on fire, and As Hyundai mentions it, it's a thermal event. So they were recalled, and one of the fixes was to add this knock sensor sensitivity code P1326, so when it picks up a specific type of knock, which could be connecting rod bearing failure, it puts the engine in protection mode, flashes the MIL like it does when there's a misfire, a severe misfire, and cuts power, limits engine RPM to 1800 to 2000 in an attempt to have the engine not blow up to the point where it might catch on fire and cause a serious problem. So some of the software was too sensitive. They found that the knock sensor wires were picking up EMI from the injector harness, so that at one point they were rerouting the knock sensor wires and replacing the knock sensor and knock sensor wires. So I'm going to find out from the dealer if there's any of this that's available. It does mention that aftermarket oil filters could cause the issue, so I'm going to put an OE oil filter on it, although I'm convinced that's not the problem. It's the right oil filter from the Wix catalog, but nevertheless I don't want any excuses. And I can't hear any engine noises, so we're going to discuss the repair with the customer, and I'll post a follow-up when I know more. Thanks for watching.